Hello, everyone. My name is Nacho Raimat, and I am a scientific programmer at the Distributed and Interactive Systems Group at CWI. And I'm here to present our submission to MMSys 2021, which is named CWIPC-SXR, Point Cloud Dynamic Human Dataset for Social XR. Real-time immersive telecommunication systems are quickly becoming reality, thanks to the advances in acquisition, transmission, and rendering technologies. Point clouds, in particular, serve as a promising representation in this type of systems, offering photorealistic rendering capabilities with low complexity. Further development of transmission, coding, and quality evaluation algorithms, though, is currently hindered by the lack of publicly available datasets that represent realistic scenarios of remote communication between people in real time. In this paper, we release a dynamic point cloud dataset that depicts humans interacting in social XR settings. We have a total of 45 dynamic sequences that some of them are single users and other multi-user scenarios. All of the sequences have been recorded with commodity hardware. That means that it's not very expensive, so it's something that people can replicate at home. And we provide the raw data, which is RGB depth and also the audio and the generated point clouds. Together with the dataset, we also release our software suite that allows, among other things, to do real-time capturing, encoding, and post-processing, and also rendering dynamic point cloud sequences. If we have a look at the state of the art, we find volumetric human datasets that have been acquired using sophisticated technologies and complex setups. For example, we have the Berkeley MHAD, which has 5 different systems: optical motion capture, 4 multi-view stereo vision camera arrays, 2 Microsoft Kinect cameras, 6 wireless accelerometers, and 4 microphones. Also the HU-MBI, which has 107 GoPro HD cameras, or the CMU Panoptic, which uses 10 Kinect cameras, along with VGA and HD cameras, and has a total of more than 500 views. Also the well-known 8-type voxelites full bodies, which uses 42 RGB cameras. We can see that some of them put their focus on the body pose and motion tracking, but not too much in realistic representation. Some of the already mentioned, like MHAD and the HU-MBI, but also the Human 3.6M, which acquires motion capturing data and then scans the user to generate avatars and uses and animates them using acquired motion data. So it's not directly capturing real movements. And we also have the Human 4D, which, they also capture the motion data, but as we will see, they also use some RGBD sensors to capture the actor and real movements. For social XR applications, we want to have point clouds datasets acquired with commodity hardware. That means configurations that can be easily replicated at home. Human 4D is closer to our goal because they also capture the actors with 4 RGBD sensors, but it lacks of texture complexity, which are mainly black due to the motion tracking suits. Also, by that time, sensors provided lower resolutions. Finally, we have the Microsoft upper bodies, which use 4 RGBD frontal cameras, so it's not a 360 setup. And as the name says, only upper bodies, so it's not the full body representation. So we present a dataset for social XR, which is divided in 4 main use cases. All of them are real-time communication. So the first use case is education and training. Here we can see some scientists, teachers, sports coaching, or book presentations. Second case is healthcare. We see some doctors and patients, but also some advices on how to wear a mask. We have communication and social interactions, where we see people watching football together or a card trick and people playing VR. And performance in sports, yeah, we have several sports like basketball, boxing, karate, but also some people playing acoustic and electric guitars. And finally, most of the actors also dancing the popular song YMCA, and they can all be played together because they are all synced. We carefully scripted all the actions. We considered a variety of gender, ethnicity, languages. There are some in Spanish, in Dutch, in Japanese, even English. And yeah, we used 23 actors to capture all the sequences. They are captured individually in the scene to avoid occlusions. But for the sequences that have more than one user, because there is an interaction, first one user recorded, and then using the audio track and the clapper, we recorded the second user and we synced them in post-production. And finally, yeah, all of this is around 2 terabytes of data, which is the raw data already mentioned, RGB, depth, infrared, and the audio, and also the point clouds we generated. Now I'm going to explain the capturing setup we used. In total, 7 Azure Kinect cameras, 6 on the side, and we decided to put one on top so it captures also the top of the head, so I don't have, or users or actors don't have empty heads. And to record the audio, we used a lavalier microphone that were carrying the actors, and it was attached to a smartphone. And yeah, then we use the clapper board to sync the streams of the cameras together with the audio. Here you can see the 7 RGB from captures from the cameras, and also the depth images and the generated point clouds for each of the cameras. Here I show you again with some pictures the setup, the smartphone with the microphone lavalier, the clapper board I already mentioned, and yeah, some pics of the actors. And yeah, after recording each sequence, we were checking that everything was good, and we already could see a rendering of the raw data. So together with the dataset, we also released the software, which is open source and is built on top of PCL. All of the components share a CWIPC object, which contains the point clouds with their coordinates, X, Y, Z, also the color, and can carry information about the camera, the raw data, like the color and depth frames. In the future, they will also give the skeleton data, probably, among others. And yeah, there are several modules like CWIPC util, which mainly has the functions to handle the objects like reading, writing, applying filters, rendering, some tools to calibrate all the cameras, to do the fusion later of the full point cloud, some tools to grab from real-time capturing or also from pre-recorded data, and a customized viewer to render dynamic point clouds. Another module is CWIPC Kinect, which allows to capture from Kinect cameras. We also have the same for RealSense, but we didn't use it in our dataset. And another module called CWIPC Codec, which has a lot of functions for encoding and decoding point clouds. As we said, because we provide the raw data, the point clouds that we provide can be modified. It means that people can generate their own point clouds by modifying the camera config parameters, the filters. for example, yeah, if they don't want the 7 cameras, they can also get, for example, here 1 camera. Here we have the point cloud generated with only 3 cameras, this one with 7 cameras. Or maybe people can be interested in also the floor or the walls. So all the data is there in the raw data, and they can modify the camera config in order to generate their customized point clouds. Here you have some examples of the dynamic sequences rendered with our CWIPC view tool. Yeah, a professor, a guitarist, and this is me dancing YMCA. So the dataset is structured as you can see here. So in the root folder, you will find the license files, the README, how to use the dataset, and all the sequences numbered and with a short description. Each sequence has inside different folders. The naming is R for roll and T for take. So for example, a sequence that has 2 actors will have 2 roles, and the takes is, yeah, if we do more than 1 take, maybe we keep both of them, or maybe we will release in the future other takes, so we can update it. And yeah, each of the subfolders has inside all the raw data, so the videos, the audio, and the generated PLY files, together with the camera config, where you have, again, all the filters that we use to generate these point clouds. But if you modify this file, you can generate new point clouds with different characteristics, and a bit of information about the sequence, description, and the duration, number of frames, these kind of things. You can find the dataset in our website. I will share it in the next slides, but if you go to the download section, you will see here the link to download. And if you are not interested in the 1.6 terabytes or 2 terabytes, you can also download the dataset hierarchy, and inside there are the download scripts that you can modify just to download the part that you are interested in. And here you also will find the software in our GitHub page. Feel free to download and use it. So this dataset, as you can see, has several applications. If we focus just on the point cloud data, you can think of different algorithms and models for immersive multimedia systems, like post-processing, compression, user adaptation, but also user experience or quality of experience for social XR use cases. Also, our software suite can allow people to play a lot with point clouds and acquire new data sets, or generate new point clouds with already published data. And yeah, because we publish the raw data, a lot of people in the field of computer vision and image processing applications can be very interested, because we are releasing a lot of materials, like different sequences captured from 7 different points of view, where you have the color, the depth, the infrared. So yeah, it's a lot of data to train new models, to play with, to extract features or new algorithms for pose estimation. They can also try to beat our calibration or alignments to do better fusion of the point clouds. Yeah, so several applications. So yeah, I think everything is explained. Here you have the website, and if you don't want to type it, you can also scan the QR code. And finally, here you have a poster frame with most of the sequences that we recorded. You can see the variety, gender, and ages. Well, thank you very much for your attention. If you have any questions, feel free to contact me. In the website, you will find my email. And yeah, last slide for the references I used in the related work. Thank you. Bye.